Deep beneath Antarctica, a world of secrets lies hidden, untouched for millennia by the hands of time or humanity. Here, time itself is locked away in ancient blue ice, preserved in a frozen embrace that stretches back millions of years. Each layer of this ice is like a page in Earth's oldest diary, recording the planet's history and preserving secrets from long before humans ever walked the land. For decades, scientists have dreamed of reaching this frozen archive, hoping to unlock the story of our planet's climate and the mysteries of its ancient past. The ambitious Beyond Epoca Oldest Ice mission set out on a quest to find ice that is at least 1.5 million years old, a true time capsule buried deep below the surface. Hidden within this ancient ice are tiny air bubbles, each one a microscopic snapshot of Earth's atmosphere from ages past, holding clues to the air our ancestors never breathed. To reach these precious records, an international team of scientists braved the remote, brutal landscape of Little Dome Sea, enduring freezing winds and endless white horizons. The ice they sought lay more than 2.5 kilometers below the surface, demanding advanced technology, relentless determination, and months of painstaking effort to extract. This mission is about more than scientific curiosity. It's about understanding the powerful forces that have shaped our world and continue to influence our future. By reading the stories written in ancient ice, we gain insight into the climate system's behavior, its cycles, and its response to dramatic changes over time. As we face unprecedented global shifts and a rapidly changing climate, the wisdom locked in Antarctic ice could help guide our decisions and protect the generations to come. The story of the oldest ice is a story of discovery, resilience, and hope, a testament to human ingenuity and our quest to understand the world we call home. In the coldest, most remote place on Earth, we search for answers, hoping that the past can illuminate a path to a safer, more sustainable future for all life everywhere. In 2023, after years of relentless effort and innovation, a team of international scientists achieved a historic milestone. They successfully pulled up the oldest ice core ever recovered from the Antarctic ice sheet, an astonishing 1.5 million years old. This achievement marks a new era in our understanding of Earth's ancient climate. This remarkable core acts as a frozen time capsule, preserving secrets from a world that existed long before humans ever walked the planet. Each layer of ice is a page in Earth's climate diary, holding evidence of atmospheric changes, volcanic eruptions, and even cosmic events. Until now, previous ice cores only reached back 800,000 years. This new record-shattering core opens a window to a critical, previously hidden chapter in Earth's climate story, doubling the timeline scientists can study directly. Before 800,000 years ago, ice ages cycled every 41,000 years, not the 100,000 year cycles we see today. This shift in rhythm is one of the great puzzles of climate science. The reason for this dramatic change has remained a mystery, until now. Scientists have long debated what triggered this shift, and the answers may finally be within reach. Finding the right spot to drill was crucial. Little Dome Sea, with its stable, undisturbed ice, offered the perfect conditions for preserving such ancient layers, making this discovery possible. Using advanced radar and remote sensing technology, scientists meticulously mapped the ice sheet to pinpoint where the oldest, clearest layers had survived the passage of time. This achievement isn't just about breaking records. It's about unlocking the story of how greenhouse gases and climate cycles interacted in the deep past, shaping the world we know today. The new core allows scientists to measure ancient levels of CO2 and methane, providing crucial data to test and improve our climate models, and helping us predict future changes with greater accuracy. It's a scientific treasure, offering clues not only to our distant past, but also to the challenges and changes that may lie ahead for humanity. With every layer examined, we get closer to understanding the powerful forces that have shaped our world over millions of years. The journey into the ice is more than a scientific expedition. It's a journey into the very heart of Earth's climate mysteries, revealing the story of our planet, one frozen layer at a time. At the center of this quest is the mid-Pleistocene transition, a turning point in Earth's climate about 1 million years ago. Before this, ice ages were shorter and milder, cycling every 41,000 years, driven by Earth's tilt. Suddenly, the rhythm changed. Ice ages became longer and more intense, cycling every 100,000 years. This shift transformed landscapes, ocean currents, and even the path of human evolution. The cause? Still debated, was it falling CO2, ocean changes, or something else? Until now we lacked direct atmospheric data from this period. The new ice core finally gives us a continuous record across this transition, revealing how greenhouse gases and climate interacted. Understanding this ancient shift is key to grasping how stable or unstable our climate system can be. Retrieving the world's oldest ice was a feat of international teamwork and endurance. Scientists and engineers from 10 countries braved the isolation and extreme cold of Little Dome Sea. Life at the camp was harsh, temperatures below -50, thin air, and relentless wind. The team used a precision drill to extract core after core, each a step further back in time. Every meter of ice was logged, preserved, and stored with care. Success depended on collaboration, from drillers to glaciologists to logistics staff. This mission pushed the limits of technology and human resolve. Each core brought new insights, fueling the drive to keep going. Their dedication in the world's harshest environment is a testament to our quest for knowledge. In the frozen silence, humanity's determination shines brightest. An ice core is much more than just frozen water. It's a layered archive, meticulously recording centuries, even millennia, of environmental change. Each section of an ice core is like a page in a history book, capturing the story of our planet's past. Every year, fresh snowfall blankets the polar regions, gradually compressing under its own weight. Over time, this snow transforms into solid ice, trapping within it countless tiny bubbles of ancient air, each one a snapshot of the atmosphere from long ago. These bubbles act as natural time capsules, preserving samples of the air that existed thousands or even millions of years in the past. By studying them, scientists can directly measure what the atmosphere was like during different periods of Earth's history. In the lab, researchers carefully extract and analyze these gases, measuring past levels of greenhouse gases like carbon dioxide and methane. This helps us understand how the climate has changed and how it might change in the future. But the ice itself holds secrets too. By examining the isotopes within the ice, scientists can reconstruct past temperatures with remarkable precision, revealing how warm or cold the planet was at different times. Trapped within the ice are also tiny particles, dust, volcanic ash, and sea salt. These tell stories of ancient winds, powerful volcanic eruptions, and the extent of sea ice, painting a vivid picture of Earth's dynamic systems. Each ice core is a multi-layered library, offering a detailed and continuous record of Earth's climate system, preserved in perfect chronological order. By piecing together all these clues, scientists can reconstruct the natural rhythms of ice ages and warm periods, helping us understand the cycles that have shaped our world. The deeper we drill into the ice, the further back in time we can see, unlocking the secrets of our planet's deep past and revealing how Earth's climate has evolved over hundreds of thousands of years. Ice cores are more than just frozen water. They are the memory of the world, holding the answers to questions we are only beginning to ask. In every delicate layer, nature has written its history for us to discover, read, and learn from, reminding us of the deep connections between the past, present, and future. Once extracted, the ice cores begin a new journey, carefully shipped to labs, always kept frozen. In cold rooms, scientists analyze each centimeter, building a timeline by counting layers and identifying volcanic ash. Computer models help date the deepest, most compressed ice. With the timeline set, researchers release ancient air from the bubbles and measure its composition. Mass spectrometers reveal CO2, methane, and other gases. Isotope analysis reconstructs past temperatures. Each meter yields thousands of data points, all meticulously logged. The results are pieced together like a giant puzzle, aligning temperature, greenhouse gases, and dust records. Slowly, a vivid picture of past climate emerges. Through this painstaking work, the silent ice finally speaks, telling the story of Earth's changing climate. In the lab, the past comes alive, guiding our understanding of the future. The oldest ice core offers urgent lessons for our time. For 800,000 years, ice cores have shown a tight link: high CO2 warm planet, low CO2 ice age. The new core lets us test this link even further back during a different climate regime. Past warm periods saw higher sea levels as ice sheets melted, vital clues for our future. Today, CO2 has soared to levels unseen in millions of years, driven by human activity. The ice shows that natural climate shifts took thousands of years. Our changes are happening in mere centuries. This rapid warming stresses ecosystems and societies worldwide. The ice core data is a warning and a guide. It shows us the consequences of unchecked emissions, but also the power we have to change course. The past is our roadmap, the future is in our hands. Ancient ice reveals the heartbeat of our planet, cycles of ice ages driven by Earth's orbit. These Milankovitch cycles set the pace, but feedbacks like CO2 amplify the swings between cold and warm. The mid-Pleistocene transition marked a dramatic change in this rhythm, likely triggered by falling CO2. The new core will show exactly how greenhouse gases shifted before, during, and after this transition. This deep perspective shows that Earth's climate is dynamic, with tipping points and rapid shifts. Understanding these rhythms helps us appreciate the delicate balance that sustains life. The ice teaches us that gradual changes can trigger sudden transformations. By learning from the past, we become wiser stewards of our world. The story of the ice is a story of change, resilience, and interconnectedness. In its layers, we find both warning and wisdom. The oldest ice core is a story of hope and responsibility. It shows what humanity can achieve through collaboration and curiosity. The lessons from the ice are clear. We know what drives climate change, and we know how to act. Reducing greenhouse gas emissions is the lever we must pull to stabilize our future. The past warns us of the risks, but also shows that the climate responds to our choices. This discovery inspires new generations to value and protect our planet. Science and exploration are our tools for navigating the challenges ahead. The silent ice gives us a voice of wisdom, speaking across millennia. It tells of a resilient yet sensitive world, and the power we hold to shape its fate. By learning from the deep past, we can protect the wonder of our living world. The message from the ice is simple: our future is still unwritten. Let's choose wisely.